Today we're going to be talking about doing some word problems with quadratics. We're going to jump right into it. I know you guys love word problems. They're so anxious to get to it. Okay. So I've got a length of a photograph is 3 centimeters less than twice the width, and the area is 54 centimeters. Find the dimensions of the photograph. I am really not all that pressed about you guys knowing how to solve the quadratics. It's just going to be setting up the equations. So let's go ahead and set up this equation. So we know that the length is 3 centimeters less than twice the width. So we've got the width, and then our length is 2w minus 3. Okay. And remember, area of a rectangle is just length times width. So w times 2w minus 3 equals 54. Now it's already factored, and a lot of people want to jump right to setting these equal to 54, but remember that rule says that we can be set equal to 0. So we're going to have to distribute this w, and we're going to get 2w squared minus 3w equals 54. Okay. And then I want to bring the 54 over, so I'm going to subtract it from both sides, and I'm going to get 2w squared minus 3w equals 54, or excuse me, minus 54. Okay, and that equals 0. Okay, at this point, I don't care if you show me the work for this. I'm not asking you to solve the equation. What I'm asking you to do is I'm asking you to solve a word problem, and setting up the equation is probably the more important thing. So let's go ahead and let's use the graphing calculator to solve this. Okay, so I've got the length of this photograph. We're going to go to the menu. I'm going to go right to equation because it's in standard form. So I'm going to do polynomial because it has an exponent. The exponent is 2, so the degree is 2. And I'm just going to plug in my coefficient. So 2 times, or 2, negative 3, negative 54. Okay, and I'm going to solve it. Now, it's giving me an answer of 6 and an answer of negative 4.5. Okay. Here's the deal with that. If w equals 6 and then w equals negative 4.5, in the real world, we don't have negative memberships. We might, or measurements. We might talk about below sea level, but we might say 5 miles below sea level. So this has no use for our word problems. So now, if my width is 6, I just find my length by 2w minus 3. So 12 minus 3, which is 9. Okay. So the dimensions of my photograph are 6 centimeters by 9 centimeters. And if we wanted to double check, remember, you just find area by length times width, and 6 times 9 is 54. All right. Now, do I know that some of you probably could have figured this out in your head? Absolutely. Okay. But we want to be able to write the equations when we get more difficult problems. All right. Our next example, it says that the dimensions of a rectangle grade on your sheet, but it should be guarded. You don't get rectangle grades. Were 5 meters by 12 meters. Each dimension has increased by the same amount, and then the garden had an area of 120. We want to find the dimensions of the new garden. Okay, so if each of my sides is going to be increased by the same amount, we don't know what that same amount is. So I'm just going to call it x. So this is x there, and this is x here. Okay, so the dimensions of the new garden are going to be 5 plus x and 12 plus x. Or you could do x plus 12 and x plus 5, because of course the commutative property applies. Again, this is area, so x plus 5 times x plus 12 equals 120. Okay, so if I multiply this out, remember I've got to use FOIL or a box or double distributive. So I multiply the first, x times x is x squared. The outside, 12 times x, so I'm distributing this x right here. Now let's distribute this 5, and I'm going to get plus 5x plus 60 equal to 120. And then I'm going to get x squared plus 17x plus 60 equals 120. Again, I need to have this set to 0. So I'm going to get x squared plus 17x. And if I subtract 120 from both sides, I get negative 120. And that equals 0. Okay. Again, you could factor, if you wanted, factors of negative 120 that add to 17. Jaden caught me. Thank God he's here. It should be negative 100 or negative 60. Go, Jaden. You deserve a pencil. All right. So this should be negative 60. I should probably do all these in front of a class. All right. So that would be factors of negative 60 that add to 17, which are going to be 12, no, it's not, 20 and negative 3. Okay. But, again, we're going to use the graphing calculator because it's that time of year and you guys are getting lazier and lazier on me, which is fine, I guess. Not really. All right, so remember we're going to just hit the repeat, or we can do exit, and we're going to put in our coefficients, 1, 17, and negative 60. And when I go to solve that, I'm going to get 3 and negative 20. So we know that x is 3, or x is negative 20. And again, we don't want a negative number. So the new dimensions of my garden are going to be 5 plus 3, or 8, and 12 plus 3, or 15. So my garden is 8 meters by 15 meters. And again, if you wanted to check, 8 times 15 is 120. Okay. So last example. Okay, a diver springs from an edge of a cliff 80 feet above the ocean with an initial upward velocity of 8 feet per second. How long will it take the diver to reach the water? And we want to use this equation. If you can visualize this, we've got a cliff, we have the ocean, and we have a little diver. And the diver goes up first and then comes straight down. Okay? This is our 80 feet. So in our formula, we're told that h is the approximate height of an object propelled upward. Okay, that would be where we're ending up, because that's what we want to know, is where we end up. Okay, t is our time in seconds, and c is our initial height. So in this case, c would be 80. This formula is used all the time when we're talking about projectiles going up. It has to do with the laws of motion and all that kind of gravity and all that kind of stuff. And it's used for the American system. There's a different formula for the metric system. Right, so if I'm going to sub things in, I want to know how long it's going to take me to reach a height of 0. and I'm just plugging into my formula. We're looking for time, so we're going to leave the time there. So negative 16t squared. Our initial velocity, v, I forgot to say that, our v is our initial velocity. So that's going to be, where is my cursor? Where are you, cursor? 8t, and then my initial height is 80. Now we could use this to find how long it will take him to get back to 80 again if we wanted to. If we put in 80, we could, how about halfway down? You could use it to find whatever time you want, but what we're curious about is when he hits the water. So his height would be 0. So again, we're just going to use the graphing calculator. And we're going to go back, and it's going to be negative 16, 8, and 80. Okay, and we're going to solve that. Again, we're going to get a positive answer and a negative answer. Negative 2 wouldn't make sense because we don't take time backwards. So we're going to go with 2.5 seconds. Okay, so it will take him, go back here, 2.5 seconds to hit the water. And again, I said that v is our initial velocity. Can't spell initial, so good thing it's right above me. Great. So today we just learned how to do some word problems with quadratics. Obviously, I can't come up with every word problem that you're going to have. Some of these are very similar to what's on your worksheet. Have a math-tastic day.